Turn to page 309. All right, section 4.6 is called numerical integration. And there's a couple different techniques they have here in this section. We're just going to do the trapezoidal rule. All right? And the idea is this. It's actually a pretty good idea. The trapezoidal rule says that the area of a region can be approximated by using trapezoids. We've approximated the area of a region by using rectangles. We can do it with trapezoids. And as you can see here with this illustration, it can make a lot of sense because by making them trapezoids, you can better follow the contours of the graph sometimes. Okay? Now what you got to realize is that each of these things are trapezoids. Okay? If you recall in a trapezoid, there's one pair of parallel sides. They're called the bases. And then the other sides, the non-parallel sides, are called legs. So for instance, those are the bases. That and that are the legs. So that's for the first trapezoid. For the second trapezoid, that base gets used again. And then there's the other base. Leg. Leg. All right. For the third one, notice that base gets used again. There's the other base. Leg. Leg. All right. Then the first base gets used again. There's the second one. Leg. Leg. So with trapezoids, we do a pretty good job of filling up that region. Okay? Now, the area of a trapezoid is 1/2 times its height times the sum of the bases. The height has to be perpendicular to the bases. Well, fortunately for us, the x-axis is perpendicular to those vertical bases. So the height is going to be the length of each one of those legs. Like that length, that length, that one, that one. That's convenient, isn't it? Okay? Everybody with me? Now, there is a formula, all right, that the book lists for us here. But I don't recommend using the formula because it's not necessarily faster, but it's quite often easier to just find the area of each trapezoid one at a time and then add those areas up. The idea of the formula is this. It makes sense. All right? If that's a base, then that's the length of it, correct? If this is the next base, and remember that next one is actually, it's the second base of the first trapezoid, but it's the first base of the second trapezoid. So it's in there twice. Then the next one's in there twice. They're all in there twice, except for the first one and the last one. So the first one and the last one don't have a 2 in front of them. All the others do. All right, but if I'm adding up all those bases, I can't forget, remember what the formula was. So what this formula is saying is do that first, but I've still got to multiply by 1/2 times the height of each trapezoid. So I've got to make sure the trapezoids all have the same height, and then that times 1/2. All right? So there's nothing wrong with the little formula. I'm not going to do it that way. I used to, but over the years I've noticed that on the AP test, you really never have to use the formula. Okay? So we'll think of them this way. So what would you do? Well, you would find the area of that trapezoid and that trapezoid. Now, what are those figures at the other ends? Triangles. But we are allowed to use those. Okay? Think of them as trapezoids with just one base. Because if I think of it as a trapezoid with just one base, isn't that the formula for the area of a triangle? And it works just fine, doesn't it? Okay? So that's different than what we did when we put rectangles in. If we couldn't put a rectangle in, we didn't count it. It wasn't a rectangle. But we can count the triangles on this. And just like with the rectangles, for the most part, the more trapezoids you put into the region, the better approximation you get. Okay? Let's do an example. So, turn to page 314. And let's try number 2. And exercises 1 through 10. Use the trapezoidal rule. We are not going to use Simpson's rule. That's not part of the AP curriculum. Okay? So use the trapezoidal rule to approximate the value of the definite integral for the given value of n. Round your answer to 4 decimal places and compare the results with the exact value of the definite integral. All right, so the integral they want us to approximate is the integral from 0 to 1 of x squared over 2 plus 1 dx. And when they say n equals 4, that means we're supposed to put 4 trapezoids into this region. So we need an idea of what the graph looks like. Well, I guess actually we don't need an idea of what the graph looks like. But let's get an idea of what the graph looks like. What was it? It was x squared divided by 2 plus 1. All right, from 0 to 1 then, it'll look like this. So, make your coordinate plane. Make the part of the graph that applies to this problem. Now, if we're going from 0 to 1, and we're supposed to divide that up into 4 subintervals, won't each one of them have a width of 1/4? Okay? So, those are the bases of the first trapezoid. That and that are the legs. And then second trapezoid, legs. I'm trying to make you be able to see the legs. It's hard to. Third trapezoid, legs. And fourth trapezoid, legs. So what we need to do then is find the area of those 4 trapezoids and add them up. Now, the height of each one is what? It's 1/4, isn't it? The height's actually horizontal. All right? So, I know this. You don't have to write this down yet. I'm just thinking. I know that I have 1/2 times the height times the sum of the bases. Isn't 1/2 times 1/4 going to be part of the area for all 4 of those trapezoids? All right? So what we need then, so we just need to know the length of the bases. And then we can figure it out pretty quickly. So let's find the length of the bases. Now, this base right here, I'm making it black now so it's different than all the others. How do I find the length of that base? What's the x-coordinate that gives us that base? 0. So wouldn't its length be whatever y equals when x equals 0? So wouldn't its length be f of 0? And then for the next base, don't give me the number. Tell me how I'd find it. F of 1/4. Right? Because that y-coordinate, whatever that y-coordinate is, that's the length of that base. So how do I find the next one? f of 1/2, then f of, and finally, all right, so do I have to figure those out before I start trying to find areas? No. I'm going to, though, just because, again, over the years, it seems like this is a pretty good process. Okay? So I know that. Now I just need to find the lengths of the bases, and I can start plugging into my area formula. So for the first, well, that's our f of x. And then for the very first base, it'll be f of 0. Now, how do I know what f of 0 equals? By using what f of x equals. Make that 0 squared over 2 plus 1. Well, 0 squared is 0, 0 over 2 is 0, 0 plus 1 is 1. So now we know the length of that very first base. Then for the next one, we've already said it's f of 1/4. So how do I know what f of 1/4 is? Well, it's 1/4 squared over 2 plus 1. 1/4 squared is 1/16. So that's 1/16 divided by 2. Well, isn't that 1/32nd plus 1 plus 32 over 32? So 1 over 32 plus 32 over 32 is 33 over 32. All right, y'all with me? All right, I get f of 1/2. That's 1/2 squared over 2 plus 1. That's 1/4 divided by 2 plus 1. 1/4 divided by 2, that's 1/8 plus 8/8, and I get 9/8. Figure out what f of 3/4 is. Anybody have an answer? I didn't get 25/16. I got 41 over 32. All right, let's see. So it'll be 3/4 squared divided by 2 plus 1. So that's 9/16 divided by 2 plus 1. So that's 9/32 plus 32/32, 41/32. And then what's f of 1? It's 3/2. Because that's just 1/2 plus 1. 3/2. Okay? Everybody with me? See why in many cases it's easier to just find them all kind of at the same time? You just kind of get in a groove, substitute the x coordinate in for x, figure out what y equals. To me, that works really well. It's worked really well in the past. So again, our area formula for a trapezoid is 1/2 times the height times the sum of the bases. The height is 1/4 in every trapezoid. So for all four of these, for trapezoid 1, I have 1/2 times 1/4 times, then I'll figure out what the bases, sum of the bases will be. For the second trapezoid, 1/2 times 1/4 times the sum of the bases. Next one, 1/2 times 1/4 times the sum of the bases. Last one, 1/2 times 1/4 times the sum of the bases. Everybody ready to find the area of the first trapezoid? All right. Which two bases are the bases of that very first trapezoid? 1 and 33 over 32. So I've got to find the sum of 1 and 33 over 32. Well, that's 32 over 32 plus 33 over 32. Well, what's 32 plus 33? 65 over 32. So 1/2 times 1/4 is 1/8 times 65 over 32. And then use your calculator. Just do 1/8 times 65 divided by 32. Math, fraction, enter. And I get, so nothing reduced. So I get 65 over 256. All right, everybody gets 65 over 256. Then we go to the second trapezoid. Make sure you use the correct two bases. What are the lengths of those two bases? Yep. That'd be 33 over 32 plus, what, 36 over 32. So that's 69 over 32. And then 1/8 times that will be 69 over 256. We ready for trapezoid number 3? What two bases? 9/8 and 41/32. So that's 1/8. 1/2 times 1/4, 1/8. So that'd be 36 over 32 plus 41 over 32. That's 77 over 32. Do the multiplication. You get 77 over 256. And do the last one all by yourself. You get 89 over 256. Okay. Now, the area of this region then is approximately 65 over 256 plus 69 over 256 plus 77 over 256 plus 89 over 256. I think I can make my calculator do that for me. I do parentheses, because they've all got the same denominator. 65 plus 69 plus 77 plus 89, close the parentheses, divide it by 256, and tell it to give it to me as a fraction. And there it is, all reduced and everything. So, think you can use the trapezoidal rule? Takes a while. Not the most complicated thing we've ever done, but it takes a while. Lots of places to make a mistake. Just copy a number down wrong and, you're off. But that's how it works. Now, the directions told us to compare the results with the exact value of the definite integral. Well, let's find the exact value of the definite integral. So, the exact area is going to be the integral from 0 to 1 of x squared over 2, or 1/2 x squared plus 1 dx. What's the antiderivative of 1/2 x squared? Uh-huh, 1/6 x to the third, and the antiderivative of 1 is x. Evaluated from 0 to 1. Be careful with your notation. All right, evaluate it for 1 first. So that's 1/6 times 1 cubed plus 1 minus parentheses, then evaluate it for 0. 1/6 times 0 cubed. I put plus 0 in there. That's not right, is it? Plus 1. So that's 1/6. Oh, it is plus 0. I looked back there. I was right the first time. All right, so 1/6 plus 1, 1/6 plus 6/6 will be 7/6. So how close were we? 75 divided by 64 is that. 7 divided by 6 is that. We were pretty close. When the directions say so. Well, duh, of course that's a lot quicker. But, I mean, here's the thing. Haven't we learned that there are some things that we don't know how to integrate and some that even if we theoretically do, it's still extremely difficult? So the trapezoidal rule gives you a good way to approximate it. The way it tends to be used on the AP test, quite often they'll give you a table of values instead of the function and say use the trapezoidal rule. So they'd give you a table of values like this. You know, it'd be like X would be 0, 1/4, 1/2, 3/4, 1. Y would be, what do we get? 1, 33 over 32, 9/8, 41 over 32, 3/2. They'd give it to you as a table and say approximate the area under of the region. Trapezoidal rule. Okay? So that's the way you're going to see it on the AP test quite often. Make sense? Hey, that's even easier, isn't it? If you just recognize you can do it with the trapezoidal rule, they've done half the arithmetic for us. Yeah. Not if, that's what I'm saying. That's even better because they've done all that work for us. Okay? All right. Questions? Of the, do we really have to do this variety, not counting? There you go. Only do the trapezoidal rule. Do not do Simpson's rule.